What's up, everybody? This is a quick video. Well, it's a video series. It's gonna be meant for people to figure out how to do our LAFD hydraulics. Particularly the person who's kind of getting off probation, trying to figure out, um, how to get certified on the engine, how to start making these calculations when it comes to the hydraulic calculator. So, very simple breakdowns. What this series is going to do is going to walk you through the hydraulic calculator, what you need to know, what you don't need to know, in the most simplest form. I know that the department already has a class in place, but this is like its most simplest form. Okay, it's meant for I remember when I was getting on probation, um, how things could have been explained to me in a little bit easier for me to understand. So that's kind of what we're going to go through. We're going to take small steps, and then we'll dive right into like the hard stuff, okay? But just breaking down the hydraulic calculator, what we're going to do right now is focus on this part of the hydraulic calculator, okay? So if you look at the breakdown here, if you follow my markings, we have hose sizes. Right here, we have our hand lines. These are our tips. Our tips they're either going to be smoothbore or spray. We got GPM. It's the total GPM that nozzle puts out, right? So our nozzles. This is the pressure that's required for those nozzles, and this is the friction loss. Okay, we'll talk about friction loss in a second. Okay, so it's a hydraulic calculator. We're just focusing on this top half right here. Okay, we're going to start is with the 1 inch. We're going to start with the small line. So this 1 inch line is what we're going to start with. If you read it, it's spray nozzle. The GPM is 40. The nozzle pressure is 100. The friction loss is 25. Okay. So let me see. Okay. So I've kind of zoomed in and just so we can focus on this one line, this 1 inch line with a 40 GPM nozzle. So if you guys remember from your inventory, the 40 GPM nozzle, it's actually capable of flowing 10 or 40 GPM, okay? So it's 10 or 40 GPM, depending on what setting you have. So anytime we're doing an equation for how much pressure we're going to pump to, we have to use a formula known as NFBA, okay? So the N stands for nozzle. The F is for friction. The B is for back pressure, and the A is for appliance, okay? So just remember that, okay? So let's talk about nozzle. If we were to add up, let's just say, here's your fire engine. Let's say it's engine 37, and we have 100 feet. So we're going to have a coupling here every 50 feet, and here's our nozzle right here, okay? Here is my N, so that's going to be 100. So according to that formula we just talked about, it would look like this, okay? We don't have any back pressure for this scenario. We don't have any appliances, but we do have friction. We're always going to have friction. So friction is going to take place from the fire engine to the nozzle, okay? So the path of which the water is going to take is going to be confined to that hose, okay? So to travel 100 feet, we're going to meet 25 pounds of pressure for 100 feet, okay? I'm sorry, friction. So if you think about a freeway, this is my little freeway. Let's say we're leaving, we're going to work at 4 o'clock in the morning. There's not many cars on the road, right? So we're able to zoom. We're able to go really fast, right? But what happens when it's the 5 o'clock rush hour and we have cars everywhere on a 2-lane highway? Well, that's when we're going to start to meet some friction, right? The cars are going to slow down. They're no longer going to be able to zoom over to wherever they're going, right? So at 5 o'clock, we meet a lot of friction. That's the same thing in a fire hose. So let's just say that we made this fire hose. Let's just say that we made it a bigger highway. We had the same number of cars, but now we have a 3-lane highway. Now it gives those same amount of cars more freedom, more room to travel faster, right? So the same thing is if we got a bigger hose with the same GPMs flowing, it's going to be less friction. Okay. If we had a smaller hose, if we made it smaller, there's going to be more friction. So if you think about it, oh, that's the wrong one. If you think about it like a freeway, that's my little analogy. Okay. So for water to go from the fire engine to travel through 250-foot sections, total of 100, you're going to need 25 pounds of pressure. Okay. So what we're going to do is we're going to factor in right where friction is 25 pounds. Okay. Now, since there's no back pressure and there's no appliance, we simply add that up and it makes 125 psi for a good working stream. Okay. Now, what is back pressure? Back pressure is anytime you're fighting gravity. Okay. So let's just say that this was a apartment complex, 3 stories. You got 1, 2, 3. If we took that hose in to the front door, here's the same fire engine. Okay. If we took the hose in 100 feet of 1 inch, like we talked about, we don't have any back pressure because we're not going up. It's all on the first floor. So we don't count the first floor. Okay. Let's just say we take the same line up to the second floor. Now we have some back pressure. Okay. So for every floor, we're going to add 5 pounds. Okay. So if we did have some back pressure, this is where we would add that. We would add 5 pounds for our back pressure here. Okay. So what that would look like, if we put it in the equation, is where the B would be. It would be a plus 5 pounds, which would make our overall pressure 130 psi. Okay. Now, it's for every 5 floors. So we took that same line and we went up to the 3rd floor. We also have 100 feet here. It would be another 5 pounds for an overall total of 10. So how that would change our equation, we would add 5 plus 5, that makes 10, and we'd add it into that equation we already had, right? 5, let me get rid of this. 3, 1, for an overall pressure of 135 pounds for a good working nozzle on the 3rd floor, which is going to be a 1-inch line. A 1-inch line on the 3rd floor. Okay, so let's talk about appliance. How does the appliance factor in to this equation? Okay, how does an appliance factor in? Okay, so if we took the same analogy of the freeway, here's our freeway. Let's just say this time we're transitioning. Okay, so we're making a turn, and we're going from, let's say this is the 10 freeway, and we're going to the 110 freeway. Now, if we're zooming through traffic, cars are moving. We come to this bend. What does the sign say? It says slow down. Slow down to, I don't know, 40 miles an hour. Over here, 55 is the speed limit. But we got to slow down to make this turn, right? Now, the more cars that are trying to make this turn, the more friction that's going to be right at this turn, okay? So for us to make that round turn, we have to slow down. Well, that's pretty much what an appliance does. So if you think about a standpipe, for example, if you had a high-rise building, let's just change this apartment that I was just talking about. We'll change it to we'll change it to 4 stories because that's when we're going to have standpipes. Okay, we'll change it to 4 stories. Here are your standpipes. Pipe runs up the side of the building. Okay, so for us to fight this turn right here, to take hose in here, plug in to each one of these inlets, and to change that direction, That's going to add 25 pounds of pressure. So the majority of your appliances are going to equate to about 25 pounds of pressure. Now we'll get into the other applications of the pressure later on. I'm sorry, the appliance and back pressure. We'll get into the more complex equations later on. But for now, in order for our traffic to make that turn, we have to add 25 pounds. There's other numbers, but like I said, we'll talk about it later. Okay. So let's just say we're going to the fourth floor. Okay. Based on what we talked about earlier, we don't count that first floor. So we have 1, 2, 3 floors we have to overcome. And it's 5 pounds for each because we exclude the first floor. We don't count that first one. Don't forget. That's going to be 15 pounds of back pressure. Okay. That's how you would factor in to that equation. So we'll add all those numbers up. And remember, this is just a quick down and dirty way. You don't even have to worry about back pressure and appliances for now. But I just want you to understand the other parts of the equation that are going to come up later on. Okay. So for now, what I want to do is we're going to give some other examples and see if we can figure out our pressure based on the things we just talked about. Okay. Make this a little bit bigger. Okay. So here's my question number 1. We have engine 37 again. Is pumping to 200 feet. This is 200 feet of hose. This total from here to here is 200 feet. Everything else is the same. How would we calculate the appropriate pressure? Okay, what we're going to do is, remember, our nozzle, our N, is going to be 100. So we're going to factor in that 100. Remember, it's 25 per 100 feet. Okay, so since we have 200 feet, we're going to take the 2 and multiply that by 25. What do we get? 50. It's pretty easy. Every time I think of 1 inch, I always think of like quarters. You're dealing with quarters. The same thing for 2.5. We'll talk about 2.5 later. So we'll take this 50 and we'll plug it into our friction. There's no back pressure. There's no appliances. This is going to be an overall pressure of 150 pounds. Okay, let's do a couple more. Let's say here's our fire engine, and they're responding to a dumpster fire. And now they're going to stretch. Let's just say they stretch. Here's our dumpster down here. Fire coming out of it. Let's just say from your fire engine to the dumpster fire is 400 feet of 1 inch. How are we going to do that? Okay, so here's our nozzle again. The nozzle is going to stay 100 pounds. And it doesn't matter if it's on the 10 setting, the 10 GPM or the 40. It's always going to be 100 pounds. Okay, 100 pounds. Okay, since we have 400 feet, we're going to multiply that by 25 because our friction is per 100. That gives us 4 quarters make 100. We'll add that to our friction. That gives us an overall pressure of 200 pounds. Don't worry about back pressure. Don't worry about appliance. So pounds of pressure, PSI, 200 pounds. Okay, let's do one more. This one I'm going to get a little tricky. Okay. All right, here we go. So let's just say that we have our engine 37 again, and they are pumping to another dumpster fire. Let's just say through 350 feet. 350 feet of 1 inch. How are we going to do that? Well, the 100 stays the same, like we talked about. And now instead of 3, we're going to do 3.5 times what? It's per 100, right? Times our 25. So you can go 25, that makes 12. 3 times 5 is 15. 3 times 2 is 6, plus the 7. It's be 5, 7, 8. Don't forget we got a decimal here, so it's only one spot that we have to move it. So 87.5, or you can go ahead and round that up to 88 pounds. So it's going to be 188 psi. Now, our compound gauge, which reads our pressure, there's no ones. It's measured in fives, right? So the closest number we can round this to is what? It's going to be 190 pounds. So on our compound gauge, we're going to go ahead and find where it says 190. Make sure that needle is pointing to the 190, and that's the appropriate pressure, okay? Or what you can do is kind of just to make things easier for you. Oops. To make things easier, you can factor in half of 25, which is roughly 12.25. 12.5, roughly, okay? So how that would look is, you know that our nozzle still remains 100, okay? And remember, it was 3.5. So let's just take 3/4, because that's easy number, right? We multiply that by our friction loss. We know that's 75. Now, if I know that 12.5 is a half a section, I can just automatically plug that half section in at 12. Or you can call it 13. You can round it up to 13 if you wanted to. But I'll just call it 12. That makes 7, 8. So I'll take this 87, bring it up here. That makes 187 psi. Now I was off by 1, but that's not really a big deal. You have a 5-pound pressure wiggle room if you wanted to, okay? So that's how we do our 1-inch line with our most common nozzle. This is the most common nozzle for a 1-inch line. Sometimes you may see a question asked like, you have 100 feet of 1 inch with the most common nozzle. So they're telling you the basic nozzle, pump 100 pounds of pressure to it. So follow this series, or we're going to keep building on this. If you guys have any questions, you can send me an email. I'd gladly go over it with you. But I'm going to keep going over the entire hydraulic calculator until everyone, understands. Okay. So let me know. Thanks.